Hey, good news. We have another episode in the Azure Enablement show in the Well-Architected series. This time we're going to do a deep dive with Niels and Sergio as we talk about improving your reliability on Azure. Welcome to the Azure Enablement show, where we'll be discussing the challenges you and our other tech-savvy customers have encountered. Together, we'll be talking with experts to find out how they think about these problems, recommended tools and best practices, and tips they've learned from years of experience that you can use. So today, we're going to be discussing improving the reliability of your workloads on Azure. So in order to get into the spirit of things, what I'm going to do is I'm going to leave my host mode and I'm going to move into customer mode. So let me become a customer. So last we left off, I was talking to David Steele about my workloads that had some outages, and I was kind of concerned about my reliability. And he gave me the basics, but suggested that I talk to Sergio and Niels about my architecture because they could go even deeper and we could do a deep dive. So I'm glad that you folks were available to talk to me today. I would love to show you my architecture, tell you what's going on, and sort of get the skinny on what to do about reliability with it. Is that cool with you folks?
Sure, that sounds great.
Okay,
sounds good.
So I'm running this e-commerce website. It looks like this. And the architecture behind this is pretty simple. It looks like this. It looks like most of the architecture you've seen. So it's got a set of front-end things, and the front-end talks to back-end services that are running on Kubernetes. Yep.
Actually, before we get into the details of the technical architecture, where we typically like to start these conversations is really taking a step back and really understanding what is the business context for this solution? What problem are you trying to solve? What types of targets does this application need to satisfy? And the reason that we do that is that we can look at an architecture and we can have a long technical conversation and generate a lot of recommendations that are technically correct, but really reliability is something that you define. And one of the outcomes of a review like this is that we want to make sure that we understand what reliability means to you and your solution. And so if we could take a couple minutes to talk about those things and talk about your application more broadly, I think we'll have a more productive conversation.
Yeah, I'm totally fine with that. In fact, David Steele did a similar thing where he wanted me to talk about what reliability was to me. So I'm totally down with this. This seems like the right way to start.
So can we start at a high level? Can you tell us what problem this solution solves for your business?
Yeah, so this is the main website for Tailwind Traders, which is a hardware business, and we sell hardware through this sort of thing. And this is meant to make sure that we can sell things. It also helps us keep track of our inventory so that we show the right thing to the customers. It's got different components to allow us to run rewards programs if we want to try to incent people to buy more stuff. It's kind of your average e-commerce thing.
That sounds really interesting. So who uses this? Are these mainly end users, external users, or is this also people that work for you?
It's mostly outward facing, is what I would say. Mostly this is how we're expecting money to flow.
Okay, and are these people located all over the world? Are they using this 24/7 all year round?
I would say that it is mostly local to the US, though there is now starting to be more outside the US traffic. So that's kind of cool. And I would say it's usually on what you would expect the usual buying cycles to be. Like
okay.
there's not a lot of traffic like early in the morning, like in the early AM time period.
Right. Okay, that's really interesting in how we look at reliability for this. We'll get back to that in a second. But is this something you developed yourself? Do you own the source code?
Yes. Yeah. We built most of the stuff is built out of stuff that we were able to do in house, working with some consultants.
Okay. The reason I'm asking that is because if you want to change something in the future, perhaps if we want to improve the reliability, then it really helps that we understand we can make changes. If this is something you install from a DVD in a server, then that's going to be a whole different approach to make that more reliable.
Okay.
Now that we have an understanding on a high level what this thing does, what it means for you, let's try to identify some targets. So if we look at reliability, there's a lot of different approaches to it. We can talk about availability. Are the components always available for you as a user to visit? But also latency, for example. If this is part of your checkout process, then you might need a very fast response because you have a customer waiting at the till. But having a slow website really hurts the user experience. If you have a website that is really slow to load, doesn't display the images properly, that's just as worse as having a website that doesn't work at all. So what we want to do is really identify the critical functions here of such a system. So can you briefly talk about the scenarios that we're seeing here in terms of user flows?
Yeah, totally. So there's different parts that are here because there's sort of the outward website, there's the mobile version, and then there's some other sort of things that are sidecar to them, like a coupon aspect and a rewards aspect. And so some of the things are important. So for example, with the coupon act, we're expecting to show people coupons as they're buying and at the point also when they're trying to check out. And so they can't be waiting for an answer from the coupon app to come back. Otherwise, the entire process grinds to a halt. And we also try to make sure that the website and the mobile stuff is available. And even if everything about the website isn't available, like our recommendation engine or something isn't available, we try to degrade a little more gracefully so that we might show like the top 10 products that we sold this week instead of showing them their recommendations based on what we know. So
exactly.
And the only other thing that I would say is that the rewards app is one that we typically use around sort of the seasonal times. We typically use it around when we're trying to incent people to buy during the winter holidays or around Black Friday times like that. That's when we'll probably bring those into bear. It doesn't usually get used all year long. We bring into bear when we want to have that extra boost to our sales.
Right. So that's good to understand. So there's different scenarios we're looking at. So for example, for this exercise, let's have a look at the website and understand the scenario there. So if you look at the architecture, that would be the ASP.NET website in the top left, supported by the Kubernetes cluster behind that, and having Cosmos DB as a data source. So now that we know that, let's identify some measures. So let's say we talk about availability. That means that every time one of your customers wants to go to the website to purchase an item from you, it has to work, basically. For example, if we measure that over a monthly period, we would like to say that, for example, it works 99.99% of the time. So the reason I'm mentioning that number is if you add even more availability, there's a trade-off. It will get a lot more expensive. And if you talk about 99.99, that's very reasonable because you'd have only 4 minutes a month that it would be expected not to be available. So how does something like that sound to you?
Yeah, that sounds right in the right ballpark. I'm certainly it sounds like where I want to aim for sure.
Okay, good. So let's have a look at some of the design considerations that would go into achieving something like that.
Okay.
So now that we have a target in mind, and one of the last ones that we talked about, we can talk about so many of them, but with regards to availability, we thought that 99.99% measured monthly was a reasonable availability target for the website that your customers use. So where do we go from here? How do we start to then design for that and see where we're at? And one of the things that we typically employ is a philosophy called designing for failure.
Okay.
Now, designing for failure sounds a little bit backwards to what we want to do. We want to design for success. But one of the reasons that we consider design for failure as a philosophy is that everything fails. And that's certainly just as true in the cloud as it is anywhere else. And so really the idea behind designing for failure is exploring what happens when something fails. So one part of that exercise, and one practical way to do that, is to take look at the portions of the application piece by piece and apply something called failure mode analysis.
Okay.
So when we look at your entire architecture, there are many components. You walked us through a coupon app, a rewards app, a website, a mobile app, and there's all kinds of other components and services that are helping to bring those services to life. When we look at failure mode analysis, however, what we want to start to do is break this down into looking at your solution as a series of key processes. So one of the processes that I have to imagine is fairly common on your website is that a customer is going to want to find an item in the catalog.
Yep.
Is that a reasonable place to start to kind of illustrate what this process looks like?
Yeah, totally, because that's core. If they can't find what they're looking for to buy, they're not going to buy, and we're going to be out of business. So
Sure.
Yeah, totally down with that.
So if we look at your architecture, then before we really dive into this exercise, what we want to do now is we want to identify the components that are involved in that process. What components, what parts of this solution have to be working in order for customers to be able to search that catalog. So it seems to me that the website itself is one of those components.
Yep.
And in preparing for this conversation, one of the things that we observed is that this website is actually a container that is also running on the Azure Kubernetes service. Is that correct?
Yeah, it is.
Okay, perfect.
We break it out just to make it easier to see where it is, but you're absolutely right.
Okay, fantastic. And so within the Azure Kubernetes service itself, there are several back-end processes that run, and you've spoken to some of them briefly, and about how you've planned for graceful degradation among them. And really, when we're looking to search the catalog and return items from the catalog, that data is really coming from Cosmos DB.
Mm-hmm.
And so if we're only looking at that key process, that is customers trying to find items in the catalog, we really only have to consider the Azure Kubernetes service, which hosts not only the website, but the backend services, as well as the Cosmos DB. Now, for the purpose of this exercise, you might have noticed that I was excluding several services to the right of Cosmos DB. And what those services do is those services basically seek to feed updated catalog information into Cosmos.
Yep.
So while we won't speak about those specifically, we will address that in the next part of our exercise. Okay? So what is the next part of our exercise? Well, the next part of our exercise, and there's quite a bit of information here, but let's look at it piece by piece. Now that we've identified the relevant components that we want to take a look at, we've gone ahead and reduced your architecture to just a couple of components to consider. And so we talked about the fact that Azure Kubernetes Service, or AKS, is where all of your web and backend services are running. So that's something we're going to have to consider. And then we also talked about Cosmos. But what you've started to see is that all of the other parts of the solution may have a part in delivering value, but for the moment, for this exercise, we're going to go ahead and not look at those. So once we have the components identified, then essentially we're looking at 4 factors. We're looking at what are all of the ways that we could imagine that each component could fail. What is the effect of that failure? What is the impact on the larger solution? In this case, the larger process, which is a customer's ability to search for catalog items. And then what do we know about the probability that that kind of failure mode is going to exist? Now, the table that we have here that we'll talk through is going to be helpful in helping to understand this process, but it's by no means exhaustive. Really, when we do this exhaustively, and it's something we definitely encourage you to do, is once you feel comfortable with what we are doing, you really want to try to apply that imagination to every possible way that you have either seen your solution fail or that you imagine it might. The more that we can plan for ahead of time, the better that we can prepare the solution to deal with those scenarios. But let's take a look at a few of them. I think fundamentally, it's hard to argue that one failure mode is that AKS may simply be unavailable. And so if that happens, the effect of that is that all of the containers running in AKS would also become unavailable. And the impact of that kind of failure is that your customer would just not be able to interact with your website at all. So this is a serious failure. In
we
terms
call
of
this bad, from my perspective.
this would be a very bad day. So when we look at probability, this is a challenge. We need to look at this not just in isolation, but we need to take into context, the larger solution. From a probability standpoint now, we're going to be looking at a mix of events that may or may not happen. The next example we'll look at is a good example of events that are hard to predict. But when we are considering Azure services that you're using, Microsoft does provide some insight, especially around availability, in the form of SLAs that basically reflect what they expect that the service is going to be able to meet from an availability perspective. So for AKS, there are a couple of things at play. There is either a 99.9% or 99.95% SLA offered on the API server for Kubernetes. And so this is the portion of Kubernetes, essentially the control plane, where we would make changes or affect management functions within the Kubernetes cluster. And this is actually something that you have to opt into. So this is a version or a SKU of the product that you have to opt into to get this SLA. So we'll come back to that in a moment, but outside of the control plane, then within our Kubernetes cluster, really the heart of what we're doing is running workloads on virtual machines. And those virtual machines within a Kubernetes cluster are covered by our regular SLA for virtual machines.
Yep.
And so we'll come back to that. Now, whether or not it makes sense to select a version of Azure Kubernetes that provides you an SLA for the API server is something that you're going to have to think through in terms of your own requirements. Is it necessary, or are you really fundamentally concerned with the workloads running on the VMs? That's a conversation that we can definitely have and dive into. For the purposes of this calculation, let's just focus on virtual machines just to make it clear how we're calculating things.
Okay.
But do know that there's an additional SLA available. So great. For AKS being unavailable, we know what would happen. We know it's a bad day. And we know we have an approximation for what the probability of failure would be. And we can take that into account in our design. The second way that things can fail is a little less defined, but nonetheless important. And that's the idea that your website performance may degrade due to fluctuations in load. So it could be a holiday season. It could be anything.
Right.
This obviously, when this happens, this isn't so much that your customers can't interact with your website, but there's a delay. And that delay may be as serious as an outage if the delay is significant. You may find your customers wanting to go to a competitor's site that isn't experiencing these kind of performance issues. So it's just as serious, and it's not necessarily dependent on a particular component being completely down. So again, the impact is that customer may leave the site, which is obviously another bad day. And now let's talk about the probability. Well, this is where things are not as cut and dry. When we're looking at Azure components, it's relatively straightforward. When we're talking about something like load over time, it is unknown. There are some estimates that you can perform. You can look back and look at previous years and see what the patterns were in terms of website usage. Or you could also be looking at trends as they are happening. If you're seeing a rise in load, we could take action based on that. But there really isn't a straightforward answer for this kind of failure. It's something where it's a good example where monitoring and automation become key, because really that's going to provide your solution the ability to react dynamically to conditions that you don't control. Okay? So from a Cosmos DB perspective, there's two different scenarios that we'll talk about. One is that Cosmos DB items may not be able to be read. So something is going wrong with Cosmos, and you can't read those items. In that case, your customers can interact with your website, but they can't perform the searches. So for the purpose of this key process, this is still not a good situation.
Right.
And similarly for impact, they still may leave your site because they can't actually get to what they're looking for. With regards to probability, we're back into another Azure service. And so if, as it is configured in your current architecture, Cosmos is living in a single region, then that is covered at a 99.99% SLA. Okay? The second case, which we won't look as deeply into, is what I referred to a couple minutes ago. It's possible that Cosmos DB cannot be updated for some reason. So these are the components that we excluded that we're doing the catalog updates. And the effect of that is that customers may not be able to find the latest items, or they may not be able to discover new items.
Sure.
And here again, reads and writes are covered equally in Cosmos DB. And so here again, we have a 99.99% SLA in terms of an expectation, from an availability perspective for this service. But that's a case that we won't spend as much time looking at. What I really want to zero in on are these two components. Because I talked about the fact that we have definitive numbers that we can plan around for AKS availability as well as Cosmos availability. But the problem is we have two numbers. And in your conversation with Niels just a few minutes ago, we agreed that we were targeting one number for availability, and that was 99.99% measured all up and from a monthly basis. And so how do we then start to do that? How can we compose those individual SLAs into a single one? Well, that's the next part of the exercise. And really, this is the last part of the exercise that we need to take for this particular process. So if we look at those same numbers that we talked about before, we looked at the fact that the agent nodes, that is the virtual machines in your Azure Kubernetes service, carry with them a 99.95% SLA. Now, the reason it's 99.95% is that today your virtual machines are not leveraging availability zones. They are, however, leveraging availability sets, and so you are benefiting from a 99.95% SLA. From a Cosmos perspective, you're only leveraging a single region today, and so again, from a platform perspective, Microsoft would guarantee a 99.99% SLA, always measured monthly in this example. And so to combine those, these are two services that must both be running in order for your customers to find those catalog items. However, they're independent from each other. So the health of one doesn't necessarily impact the health of the other. And so because of that, we multiply the probabilities together. And what we find is that the composite SLA for this process, one of your most critical processes, as you identified, is actually closer to 99.94% or just above 3 nines availability. Your original target that you specified was 99.99%. And so what we found through this looking at just one process is that if this one process reflects an important measure of availability and is largely larger than that, a good picture of your reliability expectations for this solution, then in fact we have some issues to address because they don't quite align.
So you're saying that I'm not actually going to be able to get the reliability I expected. I'm well aware that you have another meeting to go to, and I think this is a bit of a cliffhanger because now I've got to figure out what to do about this. If it shows this, any chance we could talk again sometime soon? Like maybe get on another video call like this and talk about this, because now you got me a little concerned.
Well, there's no reason to be concerned. Yeah, we could definitely jump on another
great.
call, and we can talk about, Niels can actually walk us through what it is we can do about where we are and where we want to be.
Okay, well, I definitely want to talk about this.
Definitely.
Now I'm concerned about this, but since we're out of time, I think I have to switch back over to host mode. Well, okay. Now Mia's customer is in kind of a bit of a bind. I'm hoping that you will join us in the next video. Thank you very much for watching. And I hope this was useful as we were talking about improving your reliability on Azure. Thank you very much, and we'll see you soon.